as well. Correct. Thank you, Nathan. So, without further ado, we're going to start our first talk, which is Yusuke. He works at Zillow. I think it's pretty oh, no, he's not wearing the Zillow shirt. Oh, no, it is. Okay, sorry.
Zillow shirt.
It just didn't look like it right away.
To be honest, I get a lot of those.
He's going to be talking about a tool called Zon, I believe, which is your monitoring solution for your microservices or your services. Or your infrastructure or something. Yeah, I'll let you explain it.
Thank you. Sorry.
Is this a good spot for you? Do you like this?
I like it when you're, yeah. If you're right next to me, that would work very well too. Okay. All right. Hi, everyone. My name is Yusuke Tatsumi, and it's pronounced kind of use case. If you call me use case, that's completely acceptable to me. And I'm here to talk to you today about Zon, and this is kind of really more a story about Zillow's journey from tests to monitors. So I'll start with a little bit about myself. There's my name. I am a development manager. Specifically, we tackle tools revolving around monitoring and anything that will basically help developers figure out what the heck is failing faster. I am a dev manager under the larger Velocity org, under Jonathan Altus, who just kind of gave you a little pitch. I think I'm the author of maybe the 23rd or 24th Python service. I don't know. We have a lot of those after the first one. And there's some ways to contact me. And I've been here for about 5 years. Okay, so that's a little bit about me.
Your father.
Yeah, I also just had a son, about 1 month old, so bear with me. Thank you. All right, so here's a little bit about Zillow. We were founded about almost a little bit more than a decade ago. And what you might not know about Zillow is definitely we're a real estate website. You can go to Zillow.com and you'll see that our site's right there. But we're also sort of a larger group built around making real estate better for everyone in general. You'll see over there on the right some of our brands. Our major focuses are web services and mobile applications. Web services, obviously, half of those are in Python. And you can see here that we're responsible for a pretty large amount of monthly unique users. We're skyrocketing growth there. And right now, I just checked, we're about number 42 in the Alexa USA. So a little bit about us. We do deal with scale. That's basically what I'm trying to say here. So today, I'm going to talk a little bit about first the motivation of why we created something like Zon, and then why Zon helps, and sort of what the next steps are with a service like this. So before then, I'd like to kind of rewind, take you back to the year 2014. 2014 was another year of explosive growth for Zillow. We finally arrived at 70 developers, a little bit over that number. There's 50 of us over in Seattle, and there's 20 over in India as well. So basically, you could imagine changes are just flying all around 24/7. That'll be important later. We had a monolith originally when we started building Zillow out. Probably like a majority of other companies, but we found that service-oriented architecture tended to be a better model. Fewer number of developers making commits to the same code base, keeping the API layers as a way to isolate yourselves. And we adopted that, pretty emphatically. We ended up with over 100 plus microservices after about 2 years. We had a 2-week release cycle back in 2014. And as a part of that release cycle, we had this major test pass called the AVT. And really, out of all of this, the part that I'm really interested in is this concept of AVTs. You might be familiar with scenarios similar at your own companies, but effectively for us, it standard for all verification test. It was literally our major full stack test suite. It covered every single feature in Zillow.com, part of the parts of the mobile web application, and we ended up with roughly over 4,000 test cases. A lot of them tested the browser UI interaction. It took about 8 hours to run the full thing. That's with parallelization on the parts that we could afford. It was ridiculous. And it ran twice a week. Obviously, we can't run this thing all the time, and it required a pretty huge lockdown in the environment to run because taking changes in the middle of that 8-hour pass would mean, well, there's another change that we have to verify for another 8 hours. And ultimately, we felt some pain here. Slow feedback was one of them. right? I don't know if any developer here has encountered trying to read your own code maybe 2 weeks from now, but you're like Gandalf, I don't even know what that code looks like or what the heck it did. And that's one of our major issues. Another problem we encountered is this integration with other people's code bases, right? Going back to the idea of service-oriented architecture, we had a bunch of people making changes to their own services. And obviously we like to unit test as much as possible, but even in the middle of that, you'll find that someone else made some change that relied on some behavior that you weren't expecting to rely on, and guess what? Now you're broken, and you found out about that 13 days later. Another part of it is this flakiness with the full stack test suite. Anyone who's written full stack tests on the browser, right, you've probably used some solution like Selenium or maybe Python Beautiful Soup-wise, tried to rely on making sure that everything is up on your service, including the front end layer, the back end layer, the database, and guess what? Something's down when you run that full test suite. This happened to us fairly often, and here's a slight example here. The math works out where you really can't get stability with that. Let's say we have a 6-layer deep integration here. If each one of those services guarantees a 99% uptime, your uptime is guaranteed to be 95%. It's 1 minus 0.99 to the 6th power. Add more services on there, and the number and your success rate kind of cascades terribly. And you can imagine that with something like 400 test cases, or 4,000 test cases, excuse me, we ended up with 200 that fail every single test run. Imagine being a developer having to look at those 200 test cases and decide which ones are worth looking into and which ones aren't. And this, just based on the power of probability, you're going to run into that every time, and we did. One of the other challenges is it's really hard to correlate. Imagine taking 13 days worth of changes from 15 developers or 50 developers and figuring out which one actually broke you, right? At the time, we were running into about 1,000 developer changes, daily. It was about weekly, excuse me, that's incorrect. But even weekly, right? Imagine doing a search around that. If you had everything in the same code base, you could probably do something like git bisect and probably reduce your investigation to about log of n. But imagine having to search through 8 different commits and trying to figure out what was wrong with there. And then imagine that split out across hundreds of different microservices and trying to figure out who the heck actually broke you. It was difficult. And add on top of that the fact that these changes occurred constantly, right? We have a team who's remote in India. They're working hard. They're making tons of changes. And as a part of that, you also have to look through all the changes that are made during that as well. So to sum kind of everything up in the picture, this is what we were running into. We're on this AVT boat. We're trying to get there. We're trying to test. And there's just a sea of changes that just keep coming in. And honestly, there's no way that you can actually accomplish verifying all that in time in a way that's nice for developers. So that was 2014. We took a look at that and we thought about what could we do to make this better? What did we really want here? Well, we came up with a few things. One, we need fast feedback. That 13-day pass where we just get verification weeks later, developers have no idea what they worked on. We needed that way quicker, right? As a developer, getting feedback immediately, for example, when I'm executing unit tests, is amazing. I want that here, if possible. And effectively, that kind of begets this idea of testing on every change. Fast feedback also means fast execution time. We can't have this 8-hour test pass anymore. That's killing us. Ideally, we'd like to remove flakiness. We're just throwing out exactly what we want here. And I'm not going to say that we accomplish all of it. Sorry, spoiler alert. But we're talking about, ideally, you don't want flakiness. And we want to keep the test developer-driven, and we want to kind of introduce, if possible, the idea of fast correlation, right? Even if tests run constantly, you still got to figure out exactly what service changed here and wade through all those changes that other developers have made. So with that in mind, that kind of led to this question, what actually is a change? So this is kind of one of the major ideas we struck on. Obviously, a code deployment is a change. It's going to cause some sort of service to deploy. It's going to cause some change in behavior. But the reality of the matter is there's way more changes than that. AB buckets, right? That's not necessarily a code change, but someone could make a change on some database somewhere, and that could break you. That particular AB bucket percentage. Config changes could break you. Luckily, we have our config changes in version control, but same idea. Someone completely separate from your company could break you, right? You're relying on all these third-party libraries, and ideally, right? You'd like them to keep up all the agreements that they made with you. But once again, you rely on some legacy behavior, as they call it, and guess what? You're broken, and you don't know exactly when that happened. Manual DB operations, this happens all the time, and security updates. Those need to happen, and those will happen frequently. And that's completely, and there's a lot of changes here I just want to identify that are outside of the scope of this code deployment that we were looking at previously. The bottom line is changes happen all the time. And when changes happen all the time, we really have to think about this idea of testing on every change. What testing on every change means is effectively testing continuously. So let's talk about what the ramifications of testing continuously really are. Well, one, it means that a developer cannot be sitting there looking at every single result and kind of telling you whether something's wrong or not. If you aren't already at this step, you really have to go from a manual polling to just being notified when something's failing. And as a part of that, we really need to emphasize this idea of fast and cheap execution, right? Even a test even something that takes about 30 minutes to run could end up with some changes that we weren't recognizing. And any change that is not detectable or takes a long time or any large diff could end up with 30 minutes of who knows what happened out there. Ideally, you don't want that. So eventually, our concept of tests really became this idea of monitors. Anyone who's worked in a sort of DevOps / production scenario is already familiar with the idea of monitors. You run those continuously. An example is the 500 HTTP responses you receive on your service. Maybe you monitor the 200 responses and make sure that that's up to a particular date. Effectively, what monitors are all about is running continuously so that immediately when something changes in the environment around you, you know when that happened. And you can actually figure out what changed in that particular time. Another part of that is typically you will not action off of a single data point, and we'll talk a little bit more about that later. But instead of taking a single data point, you kind of take that for a while, right? Obviously, for example, if you're tracking the 200s, there's going to be lulls potentially, or there's going to be spikes. And you don't necessarily want to action off of those. So you want to take a few data points, do some analysis on them, and then you want to alarm off of that criteria. And last but not least, fast execution time. I know I keep stressing this, but it's super important. So we decided that tests, given the current terminology, isn't the answer, and monitors really are. So our idea, turn tests into monitors. Unfortunately, I don't have enough time to discuss exactly how we accomplish some of these things, but please feel free to talk to me afterwards. We increased capacity. That's one of the major parts, to take these test cases that took 8 hours to run and sort of running them continuously. And as a part of that, we took a huge effort company-wide to re-architect these into tests that run faster. Tests that are able to do less processing to determine exactly what was failing here. So that was one part. And the other part was really take our existing AVT suite, which was ad hoc. It was basically a command line that you run. It was based off of Python's unit test, which is pretty cool. You could write a unit test style thing and actually verify your stuff. But we wanted something that actually could execute continuously and help monitor those. And that's where Zon was born. Zon stands for Zillow, Observe, and Notify. Other people might tell you different. The jury's still out on that. But here's some features that we felt were really important about Zon. It's a monitoring framework. It's using a polling model versus a pushing model. There's some reasons why we chose that, but I'm not going to go into that as well. Both are mostly acceptable for a monitoring framework, but we pull services continuously to kind of figure out what's going on and what their health is like. And then we do a lot of work to aggregate and summarize those results so it's easily digestible within an individual page on a web page. We take advantage of the concept of alarming. We notify consumers when there's an alarm that happens. And going back to the feedback idea, we track the events on the change. And to reiterate, basically we monitor services, and services define their own tests. So from a client interaction, I should also note here that unfortunately the Zon project as it stands is not open source or anything. So I'm really not trying to sell you on Zon as a service. I'm really trying to emphasize kind of what we learned from moving from a testing to monitoring solution. Anyway, the client interaction is pretty straightforward. As a service under monitor, after I've started up and I'm feeling like I'm ready to go, I register with Zon. That's basically an HTTP post request as a web service. From that point on, Zon has a definition of how your service should behave and what sort of monitors should return what sort of values. It pulls that continuously from that point on. We take those data points, we aggregate them, and then we end up with a UI like this. So let me see if I can actually see my mouse here. There we go. Okay, so one of the things I like to illustrate is right here we have a history of how our monitors actually behave over time. Each one of the colors represents something different, and effectively red is the most critical case. It means an alarm. That means that a developer needs to look into this now. This is during development time, so we have a lot of alarms. It's a good sign. It means that there's a lot of change happening. We have this on a particular time scale that's scalable, and we correlate that directly with the events that have occurred in that environment. So right here, each one of these blocks represents some sort of change that we described previously. It's either a code deploy, an AV bucket change, some sort of database reset, something along those lines. We found this is really valuable because it gives you the ability to visually correlate the event that occurred and exactly what started failing as a result of that. Aside from that, we have several rows here. The top row represents an aggregate of all of the rows below it. In this particular case, this is showing you the health of one of our test environments. Below there is a list of all of the contacts. So effectively, you're immediately given the visualization that you can see which team services are having issues, so you know exactly who to contact. So I wanted to dive in a little bit about all the different colors because there's definitely a lot of them. One of the things that we found when we were building this framework out is the idea of pass-fail just isn't enough. Even pass-fail alarm isn't enough, so I wanted to talk a little bit about why we chose each of these. We have the pass, which makes sense. This is basically saying my monitor is within the bounds or within the conditions that I've specified. That's great. I don't have to worry about that one. Fail means there might be a problem. Right, we talked about that flakiness earlier. Basically, it means that at this point, this monitor is not satisfying the criteria that we specify for it. At some point, a developer is going to have to look at it if it continues this way. An alarm is the severe case after that. Oh, sorry, I skipped manual, but I have that for the sake of completeness, but please just ignore that entirely for the sake of this talk. Alarm is basically the case after fail. If your failure continues and it fits the criteria that you're looking for, that's the moment when you notify a developer, because that means that there's been enough failures that it's something probably significant. Of course, there's lots of times when you actually examine something like that and you realize maybe it's not something I need to look at right now. Maybe it's not particularly critical, and that's why we have this next state triage. I won't go into depth right now about what that is, but effectively, as a developer, I have the choice to triage an existing alarm when I feel like it's not something critical that needs to be investigated or is blocking production. And skip exists when, for whatever reason, the monitor itself cannot execute properly. There's some resource that the monitor depends on that isn't available. So with these statuses in mind, you can continue to drill down, and you're taken down to a page that represents the individual monitor. Obviously, if we're going to replace a test framework, we're going to have to provide a lot of the functionality that exists with any test framework. So that includes detailed results about the failure itself and why it happened. This is a test detail page. You'll notice that one of the first things we emphasize is this event graph again and the status of the individual alarm. This is because we really believe in the philosophy that some sort of change is going to break you, right? Something must have happened to have caused this failure. So we want to make sure that's front and center, make sure that you know exactly who you can talk to if you think you're not the one, if you think this thing failed for, a real change that someone else is responsible for. Of course, we have some result logs to help you debug that, there's really not a lot to say here. It's just, console output, for example, from a unit test, or similar to like you would see for a unit test or something like that. And we have a little bar here that allows the developer to interact with our ticketing system to triage these tests, as we kind of explained previously, or examine what the opening issues on this particular monitor are. The event chart is kind of one of our most valuable pieces. You've got this chart here, which every single element represents an individual event. The color actually represents the status of the event. Luckily, this one has no red. Red means failure. It means that this event, within the criteria that it's specified as, actually failed. That's usually the one you'd look at first. If not, you probably look at these blue ones. This blue ones means they've never received an acknowledgement that the event actually completed. This is actually normal. We have a lot of these events that are kind of one-off and don't really submit to that. And on the right-hand side, we try to provide as much context to the developer as possible as far as what this change consists of. So despite the blurred out, you have a bug number representing maybe hopefully some sort of discussion about what this ticket's actually about, an author who you can contact, the operation that occurred. In this case, it was a deployment, the service that deployed, the change it happened to, and that commit hash here is actually a direct correlation to our change control system, which we also have in version control. That's actually especially useful because it actually tells you what the developer did in terms of upgrading versions of services or so on that could have possibly impacted the environment. Just to note, this won't be available for manual operations. Okay, so that's the event chart. And then I want to talk a little bit about alarming. Effectively, originally we attempted to alarm automatically, just send emails out as soon as we found one. What we found experimentally is that it's very hard to do that in such a way where people just aren't spammed like crazy when things go haywire. So kind of where we've arrived at, and I'll talk about this later, but our future goal is to automate this a little bit more, is to get a human involved. And Zillow already has this operations team that handles the evaluation of these alarms. So they're the ones, so as soon as any sort of alarm happens in Zon, we notify the operators, and the operators choose the appropriate recourse. Alarm criteria, effectively, an example of that is we have, there's various examples of alarms, and there's better alarming systems than ours, I'll be honest with you. But examples include n number of continuous alarms. Maybe you do some predictive modeling to see if the alarm is going to continue to kind of exceed the bounds that you're looking for. And honestly, we haven't really explored these, but having some sort of way to differentiate between the failure and the alarm evaluated off of the failure data points and how frequently they occurred has reduced the flakiness that we've encountered significantly, even without modifying the actual quality of the test itself. I should note, it's good to have a side note about flakiness. Honestly, a lot of our progress on flakiness has come from really evaluating the test case and figuring out what's flaky about them, resolving it. I shouldn't disparage that at all. However, there's some situations where despite how much engineering you have, there's external tools that you rely on that still have some inherent flakiness in them. And in that situation, we found the alarms have been incredibly valuable. Another thing that we found valuable is supporting more than just kind of the model that we've discussed previously. So in this model, we have a service under test, and Zon just pulls maybe some HTTP API on the service itself to determine its health. There's obviously other monitoring infrastructure or tools that you want to investigate and interact with, like Splunk or Prometheus or Graphite if you've worked with those as well. And Zon is designed to sort of aggregate those where possible. We support multiple different monitoring types, simple HTTP, the HTTP request. We support XUnit, which is Jenkins' sort of unit test response format based off of XML. We support, and we have under integration with internal services, both internal and external, that have helped us out. Splunk is kind of our main metric monitoring tool. And we have other services that basically help us determine what the performance of our web pages are. That's what page weight is, and client metrics. And obviously, every single type of test kind of has a better way to visualize the information that's relevant to a developer. Hence, that's why we have an example here of, for example, access log monitor, or client metrics. This kind of tells you, evaluates our access logs and tells you various thresholds that we care about, like response time and such. And we chose to represent those differently. On top of that, we have every single monitor that we have in Zon comes with some sort of JSON definition of that. That typically gets submitted with that original HTTP post I was talking about. There's some other techniques too. But Zon needs to know exactly how you want us to monitor your particular monitor. And we have a bunch of different configuration for that. You can choose the alarming criteria. You can choose the type of monitor. We allow you to tag it with individual pivots that allow you to investigate things that are specific to parts that you care about. Like, for example, the feature right? Maybe you still choose to subdivide your feature in like the data processing layer or the front end layer. We allow that subdivision, and Zon will show you that a page that reflects that. Group, the group who owns it, and the environment that it belongs to, so you know exactly what this is correlating to. And I wanted to make a note here. You can also choose kind of the frequency by which a monitor executes, and that's this period S. It doesn't always apply. Some monitors which have the push model, we ignore that value. But a huge part of that, this kind of correlates directly with the idea of making these tests faster. What we found is, as a rule of thumb, kind of making sure that every test executes within 10 minutes gives us pretty good signal. It's a balancing act. Obviously, we'd like to execute things as fast as possible. And for some of our lighter tests, like for example, things that just hit the REST API and validate some output, we test those every minute if possible. But for larger, heavier full stack tests, we found that 10 minutes is an okay compromise in between cost of the test itself and the frequency at which you can get feedback. So that's kind of, from a client perspective, how I would use Zon. For those who are curious about kind of what architecture we chose for a monitoring system like this, I've got a small diagram here. We've chosen to divide our service into kind of two main layers. One is a presentation layer that provides the UIs that we've seen previously. All of this, with the exception of service now, is in Python, by the way. Services under monitor 50/50 Python Java. We're able to easily scale to those loads pretty well. The presentation layer basically is built off of Python and React to keep that client side kind of responsive. And we have the Zon test runner, which is effectively our main worker executor, which handles all the pulling or additional processing that might be required for communicating with external sources. On the back end here, I think this is kind of the most interesting part. We have 3 different tiers of storage that we use for different purposes. At the top level, we have Graphite. Graphite is a time series data store. Basically, it stores image or float values for whatever period of time you prefer. That's what generates those graphs that you saw previously. We found that that's very helpful for long-term analytics. So, for example, if you want to find out 15 days ago, right, if there's some sort of data point that you want to measure, if it's numeric, it's really easy to kind of see how that trend happened over time. It's also great for kind of storing a lot of information with a little bit of storage. Below that, we have MongoDB, our document store. This stores our individual test result information. So kind of going back to the log output per test result that we saw, we store that in Mongo. And we actually don't keep that for a very long time. What we found is that developers tend to only need that sort of deep history for about maybe 2 or 3 days. At that point, the correlation, at that point, developers would rather just look at the issues that are occurring now. And last but not least, we have the S3 storage here. And this is mainly an artifact of kind of our older storage systems. Our older test results used to store larger bulks like, really long logs or screenshots. And we found that S3 Amazon's S3 service is a pretty cheap alternative over something less resilient that we would build in-house. So kind of going through a few of our goals here and kind of where we were at this. Fast feedback, yes, we were able to accomplish that. That's a combination of kind of Zon's architecture and philosophy in general, but really mostly lending itself to the idea that we took a hard look at these tests and really converted them into more of a monitoring philosophy and the performance that's required for that. Fast execution time just comes as a result of fast feedback, but once again, this really has nothing to do with the Zon service itself. This was a huge push that we did company-wide to accomplish that. No flakiness. I'd be lying if I said that we eliminated flakiness completely. You're probably never going to get rid of that, but we were able to reduce that to an acceptable level, right? We're not nowadays our correlation with actual failures between our 4,000 test cases, and actually we have more now. We have like 5,000, 6,000 or something like that. For the most part, 90% of those actual failures or alarms rather are something that a developer really needs to investigate. So I would say pretty close. And fast correlation, that event chart that we described previously, And I'm sorry, I didn't really talk about the architecture of the event system, but really it's just in a web service that has another MongoDB/Splunk backend, submits events, and you just query them for the number of events that occurred in an environment in a particular period of time. But really having some way to keep track of the changes in your environment is really the most valuable takeaway here. Because of that, we can directly correlate a failure that occurs in the environment with the change that happened. And there's, I didn't even talk about the best part about all of this infrastructure. We can use it in production, right? And this is amazing, at least from my opinion. The idea that developers can author, something that not only verifies the test environments, but also that can be used in the production environment as well, is huge. Zillow's organization has typically been a separation in between what the operations team manages on the production side and kind of what the developers maintain on the more test side, and really being able to provide developers with a way to push their monitors over into production has been huge. And I don't have any exact numbers, but I can tell you that the contributions to Zon in production have been a large amount, and we've actually been able to get a lot more buy-in in contrast to using, for example, the very specific production tools in production, which weren't maintained by developers before. Okay, so here's kind of what Zillow looks like now. We're at a once-a-week promotion. We've been able to have the time we have. We've wait until a promotion actually occurs. We have considerably less pain than 2014. Nowadays, if there's some sort of issue that happens in the environment, we catch it in a matter of minutes and not 2 weeks or even hours. So that's been great. And what's been really valuable about the pain that we've been seeing in testing is that it hasn't increased with the number of services we have. We've grown incredibly with the number of microservices we have. We have over 500 now, and the pain is still relatively about where it was in 2014 after we switched over to this philosophy here. And we've been able to scale developers too. So that's where we are now. And as far as Zon and where its future lies, we have some issues that we'd like to tackle. One is this failure event correlation. It could be automatic. We're still looking for the right model for that. It's kind of on the same vein as the sort of notification model. It's really hard. It's really hard for people will not trust you if your automated system tells them that someone else, the wrong person broke you. For example, they're going to lose trust in that quickly. So we're looking for a great way to accomplish that, automating the alarm emails and paging that we have done manually by operators right now. And we're trying to figure out what's a great way that we can monitor multiple data centers, aggregate that functionality as we increase the number of data centers we own as well. Okay, so summary, really the main problem that we ran into is change. Our testing solution with the granularity that was at every 2 weeks wasn't really able to handle the change we were looking at. And the way we accomplished overcoming that barrier was transitioning from testing, these ad hoc tests that happen in large gaps from each other, to continuously monitoring, continuously evaluating changes and notifying the developers. Okay. All right. Thank you very much. If you have any questions, definitely let me know. And I think I'm going to try this here. Okay. If you prefer to just type your question in the text box, there's a link here that you can try to submit some questions to. Thank you.
Alan has a question.
No, I don't have questions. I have the microphone.
Okay.
So if you have questions, yeah, clap, clap, clap. Woo! If you have questions, raise your hand. Dave. Hold on, Dave. And then anyone else with questions, just raise your hand. Keep it raised.
The questions that you submit to that link should show up on my screen. So let's hope that works.
That too. All right.
Yeah.
So it looks like you have a bunch of third-party integrations. When can we expect Zon to be open sourced?
Oh, that's a great question. I'm surprised I didn't put that in the slides. So kind of where we're at with Zon is, honestly, the integrations it has internally aren't to the point where we couldn't extract certain pieces and make them open source. Kind of where we're at is we're in the middle of a larger re-architecture for Zon, right, to handle the multiple data center story that we were talking about before. We feel like as we're making that transition, we're going to see if there's pieces that we can't make open source, especially around the reporting and maybe the test execution model. So if I had to give you, I don't have any particular time frame, but I can tell you that that's a question that's on our team's mind all the time. We love open source. Zon is built off of nothing but open source tools, and there's nothing more we'd like than to share it with you.
Well, hurry it up. just make it real quick.
You should have seen ours in 3 to 6 months before that happened. So Alan, you need it now. Yeah. Actually.
Okay. All right, let's talk after.
Is Zon linked to a ticketing system? How do you track the work that's generated by the alarms or limit randomization?
Yeah. I love how everyone's asking the questions that I want to answer. This is fantastic. Yeah, so Zon is linked to a ticketing system. Internally, we use Jira for that. And what we found is it's a lot better to just sort of vendor that to a third party than try to implement all of the ticketing and commenting and workflow aspects off of that ourselves. It's directly integrated with it, and we just have a service that where we have a part of Zon that basically keeps track of that. And based on the status of the ticket itself, it will change whether the monitor itself is triaged or not. We found that it's very valuable for developers to keep track of sort of the severity of the ticket in the Jira ticketing since it's already there. And some of the challenges that we're running into now is actually how we can kind of make the ticketing process even easier. So how we can, for example, triage multiple tickets of similar results with the same ticket number.
So you said that Zon was built on various open source platforms and whatnot, and it's also built on top of Python. Are you using any Python framework to handle kind of the massive amounts of parallelization you need for running all the monitors concurrently?
Yeah, definitely. What we found is the front end, Zon Web, is actually written off of Flask. All of that stuff is Python 2. As a part of this re-architecture, we are considering Python 3. The test runner has been by far the most expensive part of our monitoring infrastructure, and that's because we've chosen a polling model. The polling model, the Zon test runner is written off of Tornado, and that's because effectively Zon test runner, the polling model itself is effectively just ultimately a bunch of asynchronous requests to various other I/O resources, and Tornado made the most sense for that. Really, we found a lot of success with Tornado and Python 2 in particular. Not a lot of complaints actually about how that's worked, but a lot of the same caveats for async apply. Aside from that, we just use a lot of the standard vanilla libraries that you would imagine you would use in a Python service. Requests, Jinja, a lot of that, anything that you would use in a web service. So,
You have time for one more. All right, you're gonna make me run. Okay, here we go. What? I'm running. I'll make it eventually. Hopefully, I don't die. Hold on. I won't. Maybe I won't trip. I didn't trip. Okay, good.
So I guess my first small question is, do you also still have fine-grained unit-level tests running through a traditional test runner, or is this entirely replaced other testing infrastructure?
Yeah, that's a great question. And actually, a part that I really didn't emphasize on the talk actually right now is that Zon's infrastructure was built with language agnostic APIs in mind. Specifically, if you just make everything an HTTP interface, for the most part, most languages implement some sort of web framework. And we found, and from the unit test perspective, Zillow has a really strong culture of unit testing. And actually, a part that I really didn't emphasize, and this is more on like testing design, typically you want almost a majority of the coverage to be on the unit test level. And we do that. It's just that despite that, you end up with 5,000 tests anyway. But pretty much a majority of our testing is on the unit test level. And the first question our developers ask is, can we unit test it before we think about all the additional load that comes on to adding this test as a monitor system itself? But once again, keeping things, just going back to the framework agnostic part of it, in the past, our AVT test kit was written completely off of Python. And obviously everyone here loves Python. I do too. I don't see what's wrong with other people. But that was apparently a barrier for other people, for a lot of the other Java and JavaScript developers who were not comfortable with Python. So the framework agnostic part has really helped promote the idea of full stack testing in general.
One quick follow on, if you don't mind.
Sure.
What do you see sort of at a high level as the difference in sort of use cases and needs and architecture in a monitoring tool for testing versus a more traditional monitoring tool for operations?
Yeah, the main difference between testing and monitoring, honestly, is just a philosophy on testing things on a smaller level and being more granular about it. Most of the testing frameworks that you'll find don't tend to author themselves in a way that can continuously execute some sort of test. There's a lot of time that's taken in the startup and teardown, for example, and there's not a lot of thought put into this idea of executing tests in parallel necessarily. And honestly, like I said, there's obviously ways that you can augment a test framework to be a continuous monitoring framework. You just run the test thing continuously and you just hope your tests work. But it's really the philosophical change that I kind of want to impress here more than anything. And that's really the idea of making sure that your tests are granular. They test individual pieces of maybe a full workflow instead of the full thing at once. Making sure that they're testing, that the test resources that they depend on aren't combined. So you basically block one from executing from the other. Thinking about how you can make this test lighter. So a little bit of discussion about how we made our tests a lot cheaper than they were previously. A lot of our people who wrote the tests were familiar with full stack testing, and they chose that as the de facto method for testing their infrastructure. As soon as we started impressing the idea that maybe the user interaction that you're looking for can be verified by just, we can separate out this idea of the user-facing interaction of whether the JavaScript actually performs the action that you're looking for, and then just mocking or stubbing the HTTP request, and separating that out from making sure the API request actually works. We were able to make our tests considerably cheaper. And on top of that, we also did a lot of work on removing things from the full stack layer and moving them into the unit test layer as well. And really, I can't emphasize this enough. A lot of this has to do with the huge philosophical change that a lot of our dedicated test engineers took towards testing. They really impressed hard the idea of unit tests and the idea of cheaper tests. And they took the idea of moving away from these full stack tests to heart. Despite a lot of traditional experience in full stack testing and this idea of really long ad hoc test case execution. Cool.
Great. So I have one question to take really quick. So you kept emphasizing speed.
Yes.
So as a developer at Zillow, I make a change. Do I have to wait 8 hours still?
No. I
How
hope
long?
that if you learned anything from this talk, you don't have to wait 8 hours for a change anymore.
How long till I feel safe?
Yeah, so as soon as you promote a change into our common development environment, I don't want to go too high into the environment hierarchy, but we have a common one that everyone kind of ends up before they make their way to the production. Once you get into there, within about 20 minutes, you'll know.
Wow.
Right now. And keep in mind that we... And keep in mind that this is a complete replacement of our 8-hour full stack test pass. There is no concept of there is some manual testing, and I don't really want to go into that. But any automated test goes through this pipeline. There is no test that is external to this 20-minute verification, 20 to 30-minute verification at most. And then I just want to acknowledge the two people who decided to try out the slide thing. I got, oh yeah, and yeah. Yeah. All right.
Well, your experiment worked.
Cool. Thank you very much.
Woo!
Oh. And I'll stick around. You can drill me all you want. I'm happy to answer hard questions.
We have, we're gonna have a quick break, about 15 minutes, but I'm also really bad at tracking time. So get up, socialize, meet other people, meet someone you don't know. If you don't know someone, just come say hello to me. I don't think you know me. Or I probably forgot that I met you before, so we could just